Good morning students. So today we are going to study about the topic nature of acid. So let's start the lecture. So I have some pictures about the basic edible items that are used in a day-to-day life. So you have to guess or identify which kind of images they are or what kind of material or acid is being used in the images. So first image is about the salad. Something is added to the salad. What could it be? So you have to guess or mark the points or give this in the comment section. Next, the lemon. It could be lemon juice. Next, the apple. Then milk. So let's have this answer. What are these items are about or what kind of acid is being used in it? So in the first image, it's vinegar. That consists acetic acid, then lemon which consists citric acid, and then the apple which is consisting malic acid. Then milk, that is a lactic acid. So these are all kind of or sources of acid which are being extracted. So next, let's talk about the basic definition of acid. Acid are those substances which release H plus ions on being in the aqueous solution, or when they are dissolved in the aqueous solution, they produce H plus ions. So this is the basic definition of acid. So let's talk about or give a glimpse on the basic entering nature of acid. So let's talk about its application. So one of it first is the electrolytes. They are basically from the images you can see that the acid is being used in the batteries. So what kind of acid it could be? So it is sulfuric acid. There is also internal structure of the battery that is being shown. So we don't have to go deep down in the image, but the basic application is that when it is dissolved in the water, it dissociates into ions and conduct electricity. So who dissociates? It is the acid, the sulfuric acid that is being added in the battery. So next, it also the pH indicator which help in the identifying of the acid. And how it identify to being it an acid? From the scale. The scale given here show that how it behaves as an acid from level. There are basic levels from 0, 1, 2, 3 to 14. So we are only going to talk about the acid and the basic in the next lecture. So let's focus on the acidic nature. From 7, the 7th scale is the neuter. From 0 to 6, it shows the acidic nature. The substance is acidic or basic, it tells us about that. From 0, it could be the various kind of material that are being shown here. At 0, it could be a material 1, 2 could be a lemon, or various kind of material that are being shown in the picture. So we can identify from that which materials that produces acid. So it basically indicates the acidic nature. Let's talk about its next application. It acts as a proton donor as well. How it acts as a proton donor? From the given equation we can identify that how it acts as a proton donor. Proton donor basically it refers to giving of the proton. What is a proton? Proton is a hydrogen ion. So let's take example. HCl when reacts with water or in an aqueous solution, the H react with the hydrogen ion and produce hydronium ion. Hydronium ion, it is H3O positive and the leftover is Cl. So HCl donated the H plus ion. So it is considered as a proton donor and an acid. So that was an example of proton donor. So main highlights or key points of this is the liquid which consists H plus ions are considered as acid, or it's the pH scale from 0 to 6, it shows the acidic nature. If an acid dissociate completely into the water, it is considered as strong acid, or if it not dissociate, it is considered as weak acid. For example, acetic acid. oranges, lemon, grapes, they are sour in taste because it is generally consisting citric acid. Next, for indigestion, it is an example. For indigestion, we usually use the carbonate or magnesium hydroxide. For example, it acts as an antacid. For indigestion or neutralizing the acid, we use it in the form of magnesium hydroxide. Next, we are going to talk about the three major classification on the basis of acid. These are one of the important classification that we are going to study about. So, first is the Arrhenius concept. Secondly, the Bronsted-Lowry concept. Third, the Lewis theory. So, in the image we can see that the Swedish scientist Svante August Arrhenius, he was the person who defined acid as the substance which increases the H plus ion concentration when it is usually dissolved in the water. From the given equation, we can identify that how it produces from HCl reacting in aqueous solution, producing the hydronium ion and increasing the H plus ion concentration, which is usually considered as an acid. So, it's one of the merit is the neutralizing fact, that acid that react with base and produces salt and water. It's one of the merit from this theory. So, it was all about the Arrhenius concept. Next talk about the Lewis theory. So, Lewis theory, it talked about the acceptance of the electron pair. So, how it accept the electron pair? It's from the reaction given below. When A, let it be A any of the substance, for example HCl, then which react with a base. Observe that the water, it always act as an acid and base, it depending upon the situation what is being taken as an acid or base. So, water H2O act as Lewis acid as well and Lewis base as well. But here I am only talking about a basic equation which can clear it more appropriately, clear the situation. So, A plus B negative, which forms a covalent bond. Then how it form A plus? It means it's having a vacant orbital. B negative, it means it consisting an electron pair. So, having an electron pair, it donates its electron pair to the vacant orbital, which is an A Lewis acid. So, what is an Lewis acid defined by the Lewis theory? Who accept the electron pair. So, here A accept the electron pair from B which is Lewis base. So, A, it is considered as an Lewis acid and forming the covalent bond. So, it was about the Lewis acid theory. Now, let us talk about the Bronsted-Lowry theory concept. The first person in the image, he is the Johannes Bronsted. Secondly, the Lowry. These two people gave this acid theory. So, what he considered acid to be? He considered acid as a donor of proton. From the given equation, where hydrogen fluoride react with the base to form acid and base. So, he also told that the acid undergoes dissociation to release proton and therefore increases the concentration of H plus ion in the solution. So, after donating the reacting with water, the hydrogen releases to form hydronium ion and the fluoride is left as a base. So, how it considered hydrogen fluoride? Because it donated its H plus ions to form hydronium ion. So, this was about the Bronsted-Lowry theory, where he considered acid when a substance donates its H plus ion, it is considered to be a proton. So, this was all about the classification of the three major theories. So, next we will talk about in the next section. Thank you.